Hello everyone. In this lecture, let's try to understand the working principle of SPI communication, that is serial peripheral interface. Let's get started. So SPI communication allows communication between one master device and one or more slave device depending on the IOs available in the master device. And the buses that we are going to use are serial clock that is provided by the master. So only the master provides the clock for the communication, and MOSI, that is the master out and slave in. This is used for transferring the data in the master mode and receiving the data in the slave mode. And the MISO bus, which is the master in and slave out. So this is used for receiving the data in master mode and transferring the data in slave mode. And the slave select pin. Slave select pin is nothing but a GPIO in the master that is used for triggering the slave select pin of the slave. So this slave select pin is used for selecting the slave for communication by the master. Most probably SPI and I2C are mostly used for devices that are available in a single board, that is very close to each other. Before starting the communication, if many slaves are available, the master must pull the corresponding slave select pin of the slave to low for communicating with that slave. If it is not doing that, the communication between the master and the slave cannot happen. So depending on your application, you can reduce the number of buses using. That is, if you are using only one master and one slave, and if you are only transferring the data from your master to slave, or if you are transferring the data only from your slave to master, then you can minimize the number of buses as required. As you can see in this case, we are using only SCK and MOSI of the master. That is, the master is only transferring the data to the slave. So let's understand the data transmission and reception in the SPI hardware. So let's understand this with an animation. And you can see this one is the master device and this one is the slave, and this is the MOSI pin and this one is the MISO pin. And master produces the clock to the slave, and byte A, that is from A0 to A7 is available in the master, and byte B, that is B0 to B7 is available in the slave. So in the first clock pulse, data bit A0 is sent to the slave and corresponding data bit B0 is sent to the master. And in the second clock pulse, data bit A1 moves to the slave and data bit B1 moves from the slave to master. And in the next clock pulse, B2 moves to the master and A2 moves to the slave. And it goes on, and after 8 clock pulse, you can see the data byte B is available in the master, that is sent from the slave through MISO pin, and data byte A is sent to the slave from the master through MOSI pin. So this is how the SPI communicates data from master to slave and slave to master. So there are many variants of buses available in SPI. The first variant is full duplex communication variant. So in this we will be having all the 4 lines: MISO, MOSI, clock and SS. So the communication can happen from master to slave and slave to master at a time in the device. That is called full duplex communication. And another mode is half duplex communication, where the MISO pin of the master and the MOSI pin of the slave is left free, and MOSI of the master is connected to the MISO of the slave. So here also the communication can happen from master to slave and slave to master, but the thing is that this bidirectional communication cannot happen in the same time. That is, either the master can transmit the data, and once after transmitting the data, then only slave can transmit its data to the master. Either one can occur at a time. So next mode of communication is simplex communication, where we will be connecting MOSI of master to MOSI of slave, and clock to clock and slave select to slave select. Here only one mode of communication is possible. Either master can transmit or slave can transmit. Only one is possible. Bidirectionally, it is not possible for the master and slave to receive and transmit data. So this is the block diagram for connecting one master to multiple slaves. The meso, mosi and clock are common for all the slaves, and using the GPIOs or the master, we will connect the slave select pins of 3 slaves. So if this master wants to communicate with the slave 1, then this line will be pulled low. Then it will send the data, and if it want to communicate with slave 2, then this line will be pulled low by the master, then only it will send the data. So using the slave select pin, the particular slave is selected and the data transmission happens. So let's understand the communication format for SPI communication. Communication format depends on 3 different parameters: clock phase, clock polarity and data frame format. So this data frame format is nothing but the data length that is being transmitted, either 8 bit or 16 bit. And there are 2 more parameters called data toggling and data sampling. Data toggling is nothing but the change of data. As here you can see, this is the data toggling. The 0 is transition to 1 and 1 is transition to 0. So this is called data toggling. And data sampling is nothing but sampling the data lines to capture the data. This will be most often done in the mid of the data line. Here this red line is indicating the data sampling, that is fetching the data, either it is 1 or 0. So let's understand the clock polarity. Clock polarity is nothing but the bit that controls the ideal state value of the clock. So if the clock is ideal, the data cannot be transferred. The ideal state of the clock, whether high state is ideal or low state of the clock is ideal, is defined by the clock polarity of the SPI communication. If the clock polarity is reset, low level of the clock is ideal. If the clock polarity is set, high level of the clock is ideal. So clock phase. This clock phase defines the clock transition at which the data can be sampled. That is, if clock phase equal to 1, the data will be sampled in the trailing edge of the clock. If the clock phase equal to 0, the data will be sampled in the leading edge of the clock. That we will see in an example in a few more minutes. Let's see the type 1, where the clock polarity equal to 0 and clock phase equal to 0. As we know, if the clock phase is equal to 0, the slave captures the data only in the leading edge of the clock. So let's see the clock. This is the leading edge, this is trailing edge, leading edge, trailing edge. So the first edge of the clock is called leading edge and the second edge is called trailing edge. So in the leading edge, the slave captures the data. So in the following all the leading edges, the slave captures the data, that is indicated by the red lines, as you can see. In the same type, you can see the data will be changed or transition in the second edge of the clock, that is from high to low. Here you can see the meso and mosi lines is changing the data in the second edge of the clock. And also we know that the ideal state of the clock is low because the clock polarity equal to 0. So in the every second edge of the clock, the data will be changed, as you can see here. Let's take the type 2, where the clock polarity equal to 0 and clock phase equal to 1. Since the clock phase equal to 1, the data will be captured by the slave in the trailing edge of the clock. So as I said, this is the first one is the leading edge and second one is the trailing edge. The data is being captured here. You can see in every trailing edge, the data is being captured. And in the same case, you can see in the first edge of the clock, the data is being changed or transitioned. In the meso and mosi lines, you can see the change of data in the first edge of the clock. So in every first edge of the clock, the data will be changed. Now let's take the type 3 where the clock polarity equal to 1 and clock phase equal to 0. So here you can see the leading edge is high to low and trailing edge is low to high since the clock has been changed. Here the clock phase equal to 0, so the slave captures the data in the leading edge of the clock. So this is the leading edge. In every leading edge, the data is being sampled by the slave. As you can see here, in high to low, sampling is happening. High to low, sampled. High to low, sampled. And in the same type, you can see in the trailing edge, that is the second edge of the clock, the data in the meso and mosi line is being changed. Let's take the type 4 where the clock polarity and clock phase is equal to 1. That is both are 1. And here since the clock phase is equal to 1, the data will be sampled in the trailing edge of the clock. So this is the leading and this is the trailing. So in the trailing edge of the clock, the data is being sampled. That is indicated by the red dots. You can see here. And in the same type, the data will be changed or transition in the meso and mosi lines in the first edge of the clock. That is in the every first edge of the clock. So that's it. These are the 4 types, and I hope you understood the SPI communication and how it is working and what are the communication formats of SPI communication. See you in the next lecture. Thanks for watching.